Hello and welcome to the final project presentation for the class data analysis. I'm Navya. Myself and my teammates Rishika, Vishwanath, Dheeraj and Bhargavi will be presenting today's project on behalf of our entire group. Our project is about content classification on hurricane tweets to analyze the adversity. In our project, we collected tweets and classified them into different categories based on human response to adversities. And those categories are blaming the government, evacuation, grocery shopping difficulty, house damage, personal injury, power loss, water loss, and other categories that doesn't fall under this list. Content analysis on text data will be carried by Rishika.
Content analysis on text data that we collected from tweets examine the circumstances of the area during adversities. Social services and the government can utilize this classification to effectively divide people's thoughts into appropriate groups. This approach can also be used to study how people react emotionally to negative occurrences. Any person or group of individuals can use this tweets dataset specifically of this kind to categorize their views and create a situational awareness map for analysts. By pre-processing the data and applying a machine learning algorithm, we hope to categorize the tweets into pre and post disaster groups. Analysts can utilize the predictions made by this program to visualize people's physical locations as scatter plots on a map and analyze those locations in real time. Using the tweet content from the dataset, we will examine the historical data from Ida hurricane. We will utilize this data to train and forecast the category of tweet using machine learning classification models like k-means, random forest, etc. The government or local authorities can also utilize this type of content analysis to determine how many people need support across different categories and formulate plans. The data used in this project is from Ida hurricane dataset and has been collected by scraping the Twitter website during the time frame 20th of August to 9th of December 2022. The location data has been captured by team over the different cities in Louisiana. The tweet dataset contains 6,534 data points and 36 features. The description of each feature is as given below. Tweet, the actual text of the tweet. It is important because it's the actual content of the tweet. And then geo, the latitude and longitude of the place where the tweet came from. This is the longitude and latitude of Louisiana, and 100 kilometers is the range. Username of the tweeter. This can be used to get rid of tweets made by large media or the government as different to regular people. Label, the classification categories mentioned in the slide before by Navya. Creating the target column. The manual classification of tweets has been made on those classification categories and labels. Um, for instance, uh, example 1, now the power is out. That's way earlier than I expected. Carry on. We just lost power too. These tweets signify that this is power loss and they've been experiencing it personally. Example 2, there is expected power cut in Materi and expected to last for a couple of days. This category is not personal experience, and most importantly, the event hasn't even occurred yet. Uh, Similarly, we must categorize the whole dataset into appropriate categories by considering the keywords in tweet and understanding the intent of the tweet. Now let's read the data description charts and see in which category the tweets fall into. So majority of the tweets from our dataset falls under other category as it doesn't show any direct link to the other to categories like personal injury, blame the government. grocery shopping difficulty, evacuation, water loss, etc. And we have oversampled the data since we don't have enough training data set that falls under those categories. Coming in the top 10 cities with the tweet count, majority of the tweets came from Taft City and the least number of tweets came from Cheneville Town, if I'm saying that right. And the rest of the cities have more or less average tweet count.
Hi, this is Vishwanath. Now we are gonna go through how we have processed this and how we implemented the machine learning models. So as mentioned in the previous step, we have around 36 features in the data set after manually classifying the tweets into the respective categories. But we don't need all those features to train the model. So we're gonna extract only tweet location and the label. And the location column is derived from the geolocation of the tweet dataset. The geolocation column has the data in this particular format, like latitude, longitude, and the range. And we have truncated the range from this column and created two new columns like X coordinate and Y coordinate. Then we have another data frame called locations. So where it has the latitude and longitude and the respective city, we then join these two data frames and create a combined data frame and extract the city out of it. So the location column represents the city from where the tweet has origin. And the another step of pre-processing we have done is that for the tweet text, we have removed all the URLs, leading and trailing spaces, and any special characters in it. And so the machine learning model cannot directly feed on a text data. So basically, we have to convert the text data into vectors. So the fourth step of converting text data into vectors is tokenization. So if you consider a sample string here, the quick brown fox jumps over the layer. So basically, we are splitting this text into individual words. Uh, then the removing stop words. Here we remove the most frequent words like is, the common nouns and all, because these words doesn't have any specific semantic in the sentence. Then after removing the stop words, we do the lemmatization where we convert the words into their original form, like studying will be converted to study. These are the steps that we need to do for the text data to in order to pass it as an input for a model. Then, after converting the text into vectors, the one form of extracting features out of it is bag of words. So bag of words is like collecting all the words in your complete data set, the vocabulary corpus, and we create a features out of it. The one method is term frequency and inverse document frequency technique. So here we calculate the term frequency of each sentence is like the number of times the word appeared in the sentence by the number of words in the particular sentence. So that will calculate the frequency for a particular word in a particular sentence. And inverse document frequency is like mapping these words to the complete data set. So the TF-IDF is calculated by multiplying these two. This complete this complete calculation is done by sklearn's TF-IDF vectorizer that we have used. And for multivariate models, we have to use a label encoder for the city column, since text data cannot be fed into the machine learning model. So that is one another step of pre-processing step we have done. And here are the most important words that we have got from the dataset after removing all the stop words and unnecessary words. So storm, Ida, hurricane, Louisiana, power, water. So all these words talks about all the categories that we are going to classify the dataset into. And coming to the implementation, so basically we want to explore two scenarios, like how is the location feature has its impact on the modeling exercise and how it affects the model accuracies, and we want to compare different models as well. So the first scenario will be univariate models where we are going to use only the tweet as the input feature and the label as a target column, just one variable. So for the univariate models, we have used naive-Bayes, decision tree, and multi-layer perceptron and a multi-class classifier as the models that we want to compare. So here are the results of a decision tree. So it performed really bad because we don't have enough unique data for each classes where the decision tree can split optimally. And this is a pipeline, how it looks. So we are applying a TF-IDF factorizer on the tweet column and passing it as an input to the decision tree with a max depth of 10. And this is a same univariate model with naive Bayes. Naive Bayes is a generic model and it performed really well and it has a good interclass classifications as well. And the pipeline looks the same. We are going to apply TF-IDF factorizer on the tweet and the multinomial and pass it to the input as a multinomial variable. And then we have multi-layer perceptron, which is a neural network model. Here we have given the hidden input layers as 520 weighted layers, and it performed really well. But it might be a case of overfitting since we are oversampled the data. And this is a multi-class classifier. So this is a ensembling method. Here we are using a linear SVC, which is a support vector machine. And over that, we are using an ensembling method for which is called output code classifier provided by Elon to perform it, the univariate classification. And this also really performed well. And coming to multivariate models, here we are going to pass the location as one more variable. As mentioned previously, we are going to do one hot encoding on the location column and TF vectorizer on the tweet column, which will be passed to the models. We are going to use the same models here. Uh, with the location and without the location, naive performed a bit more, the 3% more accuracy compared to without location. And multi-layer perceptron is a case of overfitting. And decision tree performed well because we added one more feature to it, and it was able to make optimal splitting a criteria for the tweets, and its accuracy increased from 54% to 88%, which shows that the location does indeed have an impact on the modeling exercise, but not to a great extent. And multi-layer perceptron is also a case of overfitting because the number of features and the tweet made the model overfitting with less amount of data. Then next, Bhargavi is going to continue on how what we have found out from our experiment and the conclusion. Thank you.
Hi, this is Bhargavi. So now coming to the experiment on our own data, these are the tweets upon which the model which we have created has classified these tweets into these categories. So now coming to the first tweet, wherein power is out at house since last 2 hours, our model has classified it into power loss category, which is correct. The second tweet is that Walmart has run out of food and water today. The model has classified it into grocery shopping difficulty, which is also correct. But the third tweet, wherein it is my house roof is shredded and wrecked, it has to be classified as house damage category, but the model has classified into the other category. It's because that we doesn't have enough number of records uh, that were created in the house damage category. So that's the reason the model didn't classify it into the correct category. So the fourth category is that I am evacuating the town. So the model has classified it into a correct category, which is evacuation category. And also the fourth one, wherein the people has lost hope on the government, it has been classified into the blame the government category. So the main reason that the third tweet hasn't been classified into correct is because of the less number of records that are created from the tweets that we have collected. So now coming to the findings, the impact of the location on the data set is not very high. It's because that the data set which we have worked on has the location of the cities of only Louisiana state. But the tweets which we have collected it includes the remaining states like the nearby states like Texas and all. So we could say that the location column would have impact only when the tweets has the the tweets has the information of the hurricane that happened in the Louisiana state, but it has included the other states as well. That's why we could say that location, it has very minimalistic impact on the model performance. So now coming to the limitations, the training data doesn't have enough data points for each of the class. And also there are certain classes which has very less number of records, like about 20 to 30 records. So they are very less in general. The and the number of records are very high for the other category, but the other category, it's not very useful for our study. So we have limited the other category in our study. So the conclusion is that as we don't have enough unique data, the decision tree algorithm, it didn't perform well, but which it could have performed well in general, wherein for the classification scenario, but due to the lack of unique data, the decision tree algorithm didn't perform well. The complex models like neural networks, multi-class classifiers, which is a ensembling method, it didn't perform well with the data set, but it would have performed better with the complex data like the text data. So this is all from our side. Thank you so much.